Hello and welcome to this video on matrix modeling 3x3, where we're going to be looking at the life cycle of a butterfly. So you'll remember when we looked at beavers and chimpanzees, well, this is the 3x3 version. So a kaleidoscope of butterflies is being studied. In the study, the butterflies are divided into three categories: N, newborns, P, pupa, and A, adults, representing three stages in their life cycle, and only adults can breed. A model for the population of the colony is given by that matrix equation, where N, Np, N, and An are the respective numbers of butterflies in each category n days after the beginning of the study. At the start of the study, the kaleidoscope only contains adult butterflies, no newborns or pupa. And according to the model, after 2 days, the number of newborns is 120, the number of pupae is 105, and the number of adults is 32. And our first question is to find the number of adults at the start of the study and the number of each type after 1 day. So given that we're going to have to go backwards in time, we're going to need to use the inverse matrix. So again, here are the instructions for finding the inverse matrix for the EX and the CW, and the answer is given at the bottom, but please use your calculator to ensure you can do that. So we know that after 2 days, the number of newborns is 120, the number of pupa is 105, and the number of adults is 32. So if we multiply our inverse matrix by that, we get 150, 0, and 40. So there are 150 newborns, 0 pupae, and 40 adults. And then if we multiply our inverse matrix by our new answer, we can go back another day and see that there were 0 newborns, 0 pupae, and 50 adults. And again, something similar to what we did for the beavers, it is agreed that newborn N should be split into two subcategories, E, egg, and L, larva. An egg must hatch into a caterpillar, a larva, before it develops into a pupa. Refine the matrix equation for the model to reflect this information, assuming it takes at least 1 day for any transformation to occur. There is no need to estimate any unknown values for the refined model, but any known values should be made clear. In our original matrix, we found out that the only newborns from 1 day to the next were as a result of reproducing adults. But in our new matrix, we don't know how many eggs actually stay as eggs. But we know that no larvae are going to turn into eggs and no pupae are going to turn into eggs. But again, we're going to get 3 eggs for every adult. For the larvae, we don't know how many eggs are going to turn into larvae and how many larvae are going to stay as larvae. But we do know that no pupae are going to turn into larvae, and we do know that no adults are going to reproduce and produce larvae. For the pupae, we know that no eggs are going to directly turn into pupae, and we already know that 0.7 lots of newborns, i.e. larvae in this case, and 0.55 lots of pupae stay as pupae. And we also know that no adults are going to reproduce to produce pupae. And then finally, for our adults, we know that both no eggs and no larvae are going to turn directly to adults because they have to go via the pupae stage, and that 0.2 lots of pupae become adults, and that 0.8 lots of adults stay as adults. Thank you for listening.